Question is from the Fundamentals of Engineering exam, the FE exam, and we're given a trapezoidal shape. We have C for centroid right here, so there is a centroid of the shape, so that's kind of like the center of mass alignment. We're going to find out what the moment of inertia is around the x prime axis. So if this is the centroid here, and we have a moment of inertia called I, and we'll call this x, then we're trying to find the moment of inertia along this axis shifted up here called x prime. And it turns out there's this distance d. We're going to use the parallel axis theorem. So to get ix prime, we have to do ixx, so the moment of inertia of the trapezoid at the centroid, starting like taken about the centroid, plus AD squared. So that's the area of the trapezoid times d is the distance from your axis normally to that shifted axis, and then square it. So the thing that we'll need to find is this first one. I'm gonna highlight. I don't know if I can highlight. It's over. Okay. We got the IXX and the moment of inertia of a trapezoid about that center, the normal x axis, is h cubed a squared plus 4ab plus b squared divided by 36 a plus b. The a is the top part, so this 3 inches is the a, and then b is the bottom part, so 6 inches, and then the height is 6, so we got 6, 3 squared plus 4 times 3 times 6 plus 6 squared divided by 36, 3 plus 6. That will give you 78 inches to the fourth as your IXX. Now we need this D, so the distance from the C to x prime, we'll call this D. The D is going to be found from this y bar. This is the centroid of the trapezoidal area. Y bar is measured from the bottom right here. So the distance from here to the centroid is y bar. And we need the D, and we have 4.5 inches as the very bottom axis to this x prime. So to get D, it will be 4.5 minus y bar. So to clarify, this D right here, D equals 4.5 minus y bar. That's the gap, really, from C to here. That y bar is going to be a formula given here. I got this from a YouTube video where they just screenshotted the formula to get to the centroid. So y bar is h times 2a plus b divided by 3 times a plus b. You can find these values from Google searches, or actually in typical statics textbooks, they have these references. Probably any reference where you have trapezoidal shapes and any common shapes, you can get the centroid. Also the area, which we'll need next. Okay, so we got 4.5 minus, so we have h, which is 6, 2 times 3 plus b is 6 divided by 3 times 3 plus 6. So doing all that, you end up with 2.667. It's actually 4.5 minus 2.6667. You end up getting 1.833 as the D. Okay, we have IXX, we have D, and then now we need area. So area is simply the area of a trapezoid, so 1/2, and then we got base, so in that case it's 6 plus 3, and then times height. So 1/2 6 plus 3 times 6, and that will give you 27 inches squared. Now we have area, and we plug it all into the parallel axis theorem. So that would mean 78 plus 27 times 1.833 squared. And that gives you 168.42 inches to the fourth. So to recap, we found the moment of inertia about the x prime axis using the parallel axis theorem, and we needed to find the original moment of inertia, the area of the trapezoid, and then the distance from your original axis to the new axis. And the other equations that you needed are the trapezoidal moment of inertia and then the distance to the centroid. There you go.